All right. Thank you all for joining in on our latest webinar for the Trees Around the Globe Student Research Campaign. And I'm going to share a couple things with you first, and then we're going to get on to our speakers. And then what we can do is we can then go around and everybody wants to discuss, what they've been doing, the research they've been doing, projects or anything, or just questions about the measurements. That would be amazing. So we'll go ahead and do that. What I'm going to do right now is I'm going to mute everybody just so there's no background noise. I try to eliminate as much ambient noise as possible. So I'm going ahead and doing that. At some point, I'll ask for questions, and then we can, you can unmute yourself. You're given the option to do that. But please stay muted when the speakers are talking today, and when other people are asking questions as well. So that's just a cool thing to do because we have lots of people who want to learn about a lot of things, and it's great to have discussion with everybody. If you want to put some stuff in the chat, that's cool too. We can discuss that. I'll be monitoring the chat as we go and popping in. If you have any questions, pop those in the chat. Then that can be for me or for anybody else here that's on the presentation on the webinar. You can direct it to them. You have the option to send a message privately to somebody. That's fine. We won't see that, okay? So you have the opportunity to do that if you want to discuss and not have it all out there or taking up a lot of the chat space. So feel free to do that. So I'm going to go ahead and share my screen quickly, and then we will get going here. All right. I'm just going to pop it up this way. It's easier to do this way because I have lots of screens here on my desk, so you should be able to see this. So yeah, so this is the webinar number 3 for Trees Around the Globe Student Research Campaign. And the highlight today is going to be on a program from the Institute for Earth Observations in Palmyra Cove, New Jersey at the Palmyra Cove Nature Park. It's A-Cubed, Acquire, Analyze, Apply. And what's going to happen here is that we're going to have 2 people, John Moore and Peter Doherty from the Institute for Earth Observations, discuss with you how you can look at data in a different way and how they've been using some different programs to analyze satellite data, look at real world data, collect real world data, ground-based data. So it's a combination of that. So we'll get to that in a second. But now I just wanted to give a quick shout out, and I created a blog of this, I think it was yesterday. We have the top 5 November 2018 measurements for tree height, greenings, and land cover. And just want to give a shout out to some of these, and excuse me if I don't pronounce all the names correctly, but some are kind of tricky. So for tree height, this is over November. So for tree height, we have Jeff Bowman, Nuren Prieto, Vasil Chaishin, and Saud for tree height. And then for greenings, we have schools from Poland, Ukraine, Croatia, and you can see the names up there. I'm not going to attempt to pronounce all of those because I don't want to butcher that name. The name's too bad. And then land cover, we have from Poland, Croatia, the U.S., and Japan. So congratulations to all those and taking those measurements. There's more tree height measurements coming in every day. The greening ones are spectacular, and I know one of the things that Peter Doherty is going to show you today has to do with the seasons, and you can really look at the greenings when it comes to the seasons, as you know, if you're taking those measurements. So a little quick background of something that we want to accomplish here, and you'll notice this is in the shape of a tree. It's just something that popped up in my head the other day when I was discussing some information, actually yesterday, with Peter Nelson, our co-lead for the campaign from Oregon State University. Some of the things we want to cover throughout this campaign, since this is we're in the first year of a 3-year campaign, and there's several things that we want to do during this. And as you see with some of these webinars we've had so far, we've had experts from around the world, come in and talk about how they look at trees, and then information about exactly, how trees are measured and why this is important. So, here's kind of a model of what we want to accomplish in this campaign. We want to talk about why are trees important to measure? Who cares about looking at trees? Lots of people do. And people from all walks of life look at trees in a different way. So we want to discuss it with tree research experts, which we're going to be having in the next several webinars. through 2019. But then we want to also let you become familiar with how to look at the satellite data and the instrument data and the maps that can be created using this data. And by creating these maps, you'll be able to compare the data that you take with tree height and land cover and other measurements as part of the campaign. You'll be able to compare this data with different satellites data from like ICESat-2, from one that we're going to learn about in the near future called GEDI, G-E-D-I, which is actually on board the International Space Station. And it's mapping the world's forests. Actually, it's called GEDI, May the Forest Be With You. So a very cool play on words there. But then also, I think what is the most important part is the student data and making sense of it. And when I say student data, I'm talking not just about the globe measurements that you're taking, but also the cultural aspect of what you're measuring. For instance, next year we're going to have a presentation from a group in Montana. It's a tribe called the Salish tribe. And they're taking tree height measurements and land cover measurements, but they have a totally different way of looking at trees culturally within their tribe. So we're going to be talking about that as well. And we're going to be asking for you in the near future to share with us what cultural aspects of looking at trees and forests and land cover you have in your area, in your local area, in your country. So we can create some, it's kind of like a map of, why trees are important culturally. And then also with all this information put together, we really want to highlight global student and school collaboration networking. So basically, if you are part of the ENSO campaign that we had the last 3 years, we really stressed collaboration among globe schools, and not just regionally or in your country, but all over the world. We had schools in Ohio and Michigan working with schools in Ghana and Nigeria and Croatia and Poland. So we had schools looking and taking the same data during the same time period, but then they were using that and comparing each other's data, comparing, contrasting, see what was going on globally to understand, the local environment, helping to understand that global picture. So I'll keep this. I'm going to show this little map here every time we have a webinar, because I think it's good. This is what we want to cover, in the next 3 years. We want to focus on these things. And this is after an exhaustive conversation between Peter Nelson and me yesterday, really focusing on, how do we, when you talk about the world's trees and the world's forest, that's a lot to talk about. So how do we, fine tune it for this campaign? And this is, kind of what we came up with. It might change now and then based upon demand and what the students and teachers want, and eventually citizen scientists. But yeah. So as you know, the campaign can be found here. This is the long URL to it, but if you just go to the Globe page, you can find a link under the campaign section and do Globe. And I wanted to give your attention to our next webinar campaign webinar is actually going to be next week already. And it's going to be Getting Tree Science Done, live from the Shoemate Middle School in Gibraltar, Michigan. And what's going to happen here is that Jeff Bauman, a Globe teacher, very well-known Globe teacher, is having 3 of his students going to present the research they've been doing with tree height and some ice and its correlation to the ICESat-2 satellite, as well as some land cover stuff and some of the other measurements they've been taking. So this is going to be December 3rd, so next Monday at 8 p.m. Eastern Standard Time. So it's going to be different than this 2 o'clock, normal 2 o'clock. It's going to be at 8 p.m. and that's 1 a.m. UTC December 4th. So I apologize for those of you who have to come into the middle of the night, but this is the best time that works out for his students, and he's also a college professor, so this is the time that really works out the best for his group. Around of this image, you will see lots of notes that are up on the board all the time, all the measurements that they've been taking. As you can see here, you can see tree heights, tree type. You can see clouds, surface temperature, hydrology. So they're doing salinity and pH. So they're doing lots of cool things, and a lot of this ties into the Trees Around the Globe Student Research Campaign. So without further ado, I should mention, does anybody have any questions about this before we get started on the feature here? And you can go ahead and unmute yourself if you need to. All right, so silence is golden. If that means no questions, I guess. If you have any, think of any, just put them in the chat or pop to the end. Wait to the end of the webinar. Well, who I want to introduce right now is John Moore. He's the Executive Director for the Institute for Earth Observations at the Palmyra Cove Nature Center in Palmyra Cove, New Jersey. And Peter Dorothy is the Director of Science, Technology, and Education at the Institute for Earth Observations at Palmyra Cove as well. So they're going to talk to you about the Acquire, Analyze, and Apply A-Cubed program, and they're going to show you some really cool stuff. And I just saw something this morning when we were doing some technology testing this morning, some really cool stuff that they put in the museum, and that that you can, it'll show you, it'll demonstrate how you can do stuff that they're doing, but do it on your smart devices. So I will go ahead and stop sharing, and I will pass it over to John and Peter. Welcome, John. Welcome, Peter.
Hi, Brian. Thanks. And hello, everybody. It's a pleasure to be here. And so I'm John, and we're going to, as Brian said, we're going to go through a couple of things. Don't leave early, though, because we're going to show you Hollow Globe. Pete's going to be showing you that. That's going to be something that you're going to want to get involved with. So we're going to start with, I'm going to share my screen. We're going to do a PowerPoint, and then we'll go back live. So we're here in New Jersey, by the way, as Brian said, just a little bit north of Philadelphia on the Delaware River. So that's where we're coming from on a cloudy and relatively chilly day here. Brian, you need to enable it.
Again, it's crazy. All right, there you go. It must reset every time. There you go. Should be able to do it now.
Okay. Okay, so as Brian said, this is a project we've been working on, Acquire, Analyze, and Apply, or A-Cubed, as we like to say, because it's a little bit faster. The idea here is to look at data of all types of data, globe data, satellite data, remote sensing data, wherever it comes from. And in a kind of a learning paradigm here, these are kind of boil it down after many years of thinking about this. This is what it's about, is to acquire the data, analyze the data, and apply it. So a lot of times in the schools, we don't get to that last part of apply. And so we want to think about that today as we're talking along. I want you to notice for a second the subtitle, to observe the Earth and visualize the future. That actually came from my students many, many years ago when I taught in a career technical school, and we were there with commercial foods and printing and auto mechanics, and we were geoscience and remote sensing. So we're saying, well, what do we do there? Well, it's kind of a little play on the words. We're observing the Earth, but to visualize the future has to do with computer visualizations as well as for the students to visualize your future. So that's one of the things that you might have questions for me today, are the careers that go along with what we want to show you today. Okay, so again, to start off slide, we just talked about that. But down the bottom, this tagline, a pathway to data literacy. This has been a big topic lately in looking at data. So for many decades, we've been introducing data. NASA, NOAA, NSF, Academy of Sciences are all about data, making decisions based on data. But in the pre-college world, or in K-12, what is the data literacy? So we're hoping to answer some of those questions as we go along too. Just a little bit about us here at the Institute for Earth Observations. Basically what we've created in our center is an Earth monitoring station, and there's different aspects, as you can see going down the left-hand column there, is that it's about observing the Earth in real time. Where does that come from? Either from NASA, NOAA, again, NSF, any live sites, European Space Agency, many, many sources of data. To introduce GIS, then some image analysis programs that we use here, as this is from Globe, And Pete's going to talk to you about virtual and augmented reality in a little bit. And of course, the Globe field observations. And we have an innovation engineering lab that goes in that we're using for virtual reality. The idea here, we have a 250-acre nature park, and the idea is to be outside in the trees, doing the observations, but then bringing in and share data and information globally. I want to give a shout out talking about careers. This is a friend of mine from about 5 years ago, Hal Walker. And the thing here is for the young people, how many of you recognize that white long thing there? That's called a slide rule. And so I saw Hal give a presentation, and his quote is up there, is that we went to the moon with a stick. So the significance of Hal here, and some of you that are Big Bang fans on TV may have seen the boys do this experiment. But Hal Walker, in 1969, along with Buzz Aldrin, first men on the moon, set up these mirrors and lasers to test and verify some physics. So he is a true, as the words say, a hidden figure, because as you see, as an Afro-American man in the late 50s and early 60s, he was the head engineer on that. And I have the privilege of knowing him and working with him on a couple of projects. So I want to let the young people all know about Hal, because he's a true inspiration. So a little bit of stuff in the background, making the case and why we're doing Globe and why we're doing things like the Trees campaign within Globe. Because we're talking about science versus science education. So right now, we're looking at, and I think most people agree, there's a national science agenda. We have very important things that we have to deal with. Trees, climate, water conservation, agriculture, diseases, all those things are topics that affect each one of us. And my question to bring this up when you're doing research and to think about this is, are we in schools doing real science that fits at least the U.S. Science agenda? Other countries that may be online have their science agendas. But the question I'm putting out there, does science education, in other words, students, are you learning in schools anything about what is going on in these areas? Being an environmental scientist, I know that generally across the schools in the United States, even an earth science class is hard to come by. So there is a national science agenda, as you can see on this slide, and they're the players that make that happen. One of the things that we developed here is Earth System. So this is our STEM approach. And the main points here, as you can read, it uses satellite remote sensing. But on the other side, you see kind of the Venn diagram here. All these words are out there, and that helps hopefully clarify some things, because all these things cross over each other. People call them by different names. That's one of the things that's confusing. But you can see that we can move this in the direction. So one of the things that we generated here, the SEAS model, space to Earth, Earth to space. And the idea is simple. The idea is that we can go out, use the GLOBE protocols, or use traditional environmental science, or biology, or any type of outdoor field exercises or field studies, and collect data. But now the students around the world have the opportunity to compare this to the satellite data. And that's exactly what the TREES program and project is. We're comparing our tree data to the recently launched ICESat data. Now, how do we do this? It's this quick thing. You can look it up on the GLOBE homepage. If you don't want to do ICESat, or you're big on satellites like I am, here are all the different satellite programs that are all there, ready to go. Just have to go in, read the directions, and you can be involved with doing that. ICESat 2, we don't have to spend much time because you're all ICESat people, but this is the latest one, as you know, and it's an interesting thing to introduce trees, as Brian said. Another shout out for some GLOBE observers. This fits in. So you're looking at this acquire and analyze and apply. So these are ways that you can acquire data. The application is actually doing that, putting in the data points in there, but you can see it's a picture on the left side of New Jersey, but you can acquire data. So this is things that a lot of people like myself spend a lot of years looking at. How do you acquire data? That was not possible not so long ago, but it's getting easier every day. And then we look at the Landsat satellite, which ties into the land cover. So we sit here and say, you know, you've heard that a picture is worth 1,000 words, but look at the statistics here, how much information. So on the left, you see all the globe by the numbers, but one satellite pixel and satellite image can be over 400 million data points. And what you're looking at, the green blob again is New Jersey, and the black squiggly line is the Delaware River. Okay, and so the latest thing that's out on the Globe Observers that hopefully all of you have already used, I see some of the data that Brian showed you, is the land cover Adopt a Pixel. Cool thing, able to use. Just going to show you this quick video that's online. It's about just a couple seconds here.
Become a citizen scientist today with GlobeSat.
Okay, so you saw our trees there at the end. This is not fast forwarding here. I need to do this. Hold on 1 second.
There seems to be a lag, basically. Okay. There you go.
Okay, so one of the things we're talking about in the AQ project is big data. That's another topic to research and put into your research students if you're looking at putting together some support information. But big data is a large initiative, and guess what? The geosciences, the GLOBE program, satellite data, it makes up a large proportion of the data. Here's the Earth observing satellites. Many of you have seen this, but you can see over here 9 petabytes of data are brought in just in the geosciences. So this is the information that we have out there. Now moving a little closer into what we did here with this project that we did with the NSF and some local GLOBE teachers here was, this is what we want to talk about for a few seconds, is creating your own imagery. So you can either take it from the internet or get it from NASA or NOAA or somewhere, or we can begin having students generate their own data. So the picture there with the green and red over there is a thermal image that was created at one of our GLOBE teachers' schools, and that's a thermal image, and we got that through using some drone technology. In the center, you see a couple of the teachers out in the field, so we collected surface temperature data, cloud data, you know, a lot of net data, because that affects the thermal footprint you'll see. One of the other pictures we have here is one over on the left. That was the actually GLOBE SRS in 2017 that we hosted here. And the point we want to make to the teachers here is that a lot of times when you're doing education, the word assessment creeps into the discussion. Our position here as scientists is when we see this many people and these young people that have done science, put together a scientific poster, and can sit there and defend it orally with pretty high-profile examiners, we feel that that is a success story. Okay, these are just some of the pictures up closer. So how we did this was we flew drones over the area and used a software program called Drone Deploy and created this thermal image. The reason that this is important, we had on the board before the information about Landsat. So Landsat also produces a NDVI, a National Vegetation Index. So this can kind of look at a ground version, ground truth version of what you're seeing from Landsat, but it's higher resolution. So when we started working on this, knowing that ISAT was going to do the tree elevations, this gives us a closer view. So Landsat, you know, it's out a little bit further, the resolution isn't as high, but you can pick out, you can see yourself on these pictures, you can pick out these trees. And then if you're doing the tree protocols, you can be outside, start picking these trees. If you know a little bit about GIS, you can actually mark the location and create all these images together. And it's about layering. This picture was put together, this is a mosaic, and we'll show you, give some credit at the end, to another NASA CAM project called the ARIN project, and this is about flying kites, Aerocats. And so we had a couple students go out and we flew this over our study site, and they used GIS and created a mosaic image. The point here is that we're acquiring the information ourselves and we're analyzing the information ourselves, and then we can apply it in a study. Here's a couple other views over up in the right-hand corner is the drone picture. That's the self-portrait from the drone. And plus, that's just fun to fly those things around. But you can see you can start creating all these images, but a little higher resolution because you're lower to the ground. So let's say you don't have drones. You know, we try to do things here that everybody can work on. Pete put these things together right off of Google Earth, and you can look and change the RGB factors and change what you're looking at depending on what you want to study. So it's a kind of a visible image. Next one, there's the thermal image, and this was out in Toledo, where those people that we work with, the Globe Mission Earth project there, and we were out there working with the Globe teachers out there, and so this is of the local area. The point is, you don't have to use this data. You can go anywhere on the globe and find your own data. One of the things that we're working on now that we want to give a shout out for, because we think it all goes together, is the Earth System CubeSat Challenge. So you may have heard yesterday, if you all were watching the Mars landing, that there are 2 support vehicles, if you want to call them that, and there are CubeSats. So CubeSats are these 17 centimeter squares. Then they can, so they were used yesterday. We're looking at this as developing, so NASA has programs that you can fly. That's very expensive, so this is a step down where teachers and students can start getting information. Here's a little just quick go over of what Mission Earth is. You can look that up if you Google it or go to Globe. You can find out what we're doing there and a lot of information that's going on across the country, and a lot of different things, and it's focused on STEM. And then here's a little blurb. This is also a NASA CAN project with Aerocats and rover education. The themes here are getting real-time information generated, again, back to the AQ, acquire the information, let's analyze the information, and let's then, the important part for the future is to apply it. So we're going to get ready to hand you off to Pete. Like you've seen this image, you hold the whole Earth in your hands. So what we're working on here, the HoloGlobe project. So what if I was to tell you that I could have this is called a merge cube. So it looks like something from Star Trek and the Borg, I know, for those Star Trek fans. But what if I could take this and then turn it into actually an Earth? So you can say, well, that'd be a nice trick if you could do it, John. Well, I can't do it, but Peter can. So we're going to get Pete up here in a second. So this is called the HoloGlobe. This is a free app that can be downloaded on Android phones or iPhones, and it's free. You can go to your app stations and download them. And we're going to show you what this is going to look like, and then Pete's going to give you a live demo. So what you're seeing here now is the Earth with data sets on it, and what the young lady behind is holding is that square merge cube. And yet we have a 3D visualizations. This can go out. There's GPM data. Dorian, I know you're online there. So there's our GPM data, and we can show that. Okay, let me get this to move to the next page. There we go. So on Hollow Globe, we want you to know that Pete was the coder for this. So all those talking about careers, let's say, I doubt anybody out there with fitness category, but let's say you don't really care about the environment. You're more of a computer person and like doing coding. Well, we can use you in our projects too, because this is all about coding. And it helps to know about the environment. We'll make environmentalists out of you. Pete's trying to make a coder out of me. I'm too old for that, I think. But on Hollow Globe right now, you can see the satellites that are out there, and he's going to show you that. We'll come back to that later, and so I'm going to stop sharing. Stop sharing, and we come back to live. So I'm going to hand you over now to my colleague, Pete Dorfey.
Hey, hello everyone. So as John was mentioning about augmented reality and the use of this cube, so let me show you what this cube actually looks like. I'll bring it up to the camera here. It's called the Merge Cube, and it has these patterns all over the cube. And the idea behind augmented reality, especially using mobile phones and mobile devices, is that the camera on any mobile device will actually video these patterns, and the software inside the device will actually start tracking that pattern in space. So you can rotate the cube and it will track all the pattern in 3D space. And then a developer would add content, digital content to that cube, so you can put anything you want. So basically, for example, Pokemon Go is probably one of the most popular augmented reality apps that people know of, especially children. They know Pokemon Go. But that works on the basis of GPS. So the idea is that you walk around and your device's GPS will recognize the spot that you're at and will render a Pokemon character. So kind of the same way, but instead of using GPS, this platform uses an actual physical target image to actually develop or put content to. So this is a small cube. These go for about $15 in Walmart. There's a whole bunch of augmented reality apps. Augmented reality is basically the next evolution to virtual reality. Most people are familiar with virtual reality. It's been around for a long time. Virtual reality is completely being immersed in a computer-generated world, like the Matrix movies or something like that, where everything is not real. Everything around you is computer fake, you could say. Augmented reality is simply using your real environment and then augmenting it with computer content. So the newest term that Microsoft is using, is pushing through Google and all that, is something called mixed reality. So mixed reality is basically, it's augmented reality, but it's more interactive. There's more interactive from the user. So that's kind of the new phrase, is mixed reality. So anyway, here's a small cube. And then we've kind of played around. We've gone from bigger to bigger. We had an 8-inch cube, and now we have like an 8-inch cube here. And in just a moment, I'm going to show you a 2-foot cube. But for now, let's work with the small cube. So I'll work with this, and I'm going to bring up the app, the augmented app called Hollow Globe. So I'm going to do a share screen here to get this started. And I'm going to mute this. And everybody should hopefully still hear me. Thumbs up. Okay, awesome. I'm going to share content. Let's see here. Okay, you should see my iPad screen, and I will bring up the Hollow Globe icon, which is, you can look in the lower right-hand corner here, called Hollow Globe, little Hollow Globe icon. There we go. We'll give that a moment to start up. So this is the front page of the app, and it will go into phone mode, which is the most popular mode. So we're going to start that up. Now you might get some lag here because I'm using wireless connection. So as I kind of interact with the app,
there'll be obviously some lag. But this kind of, without any augmented reality technology, this works as a regular mobile app. I mean, there's apps like this already online. NASA has put out stuff like this, basically, mobile version of the Earth where you can actually add satellite data to it. So, for example, the blue squares you see around the Earth represent actual data sets. So, for example, the clouds in the upper left-hand corner, if I press that, I can go ahead and download the latest global cloud coverage. Now, all these data sets are coming from NOAA's Science on the Sphere. So anything that's on NOAA's Science on the Sphere, which is basically a $150,000 installation, we can put right here into a little cheap $15 cube for everybody. So anyway, but we can get all those data sets on here. And I just have some of the data sets, some of the more popular data sets, you could say, the more useful ones. But again, I can move this around, rotate it. I can actually add overlays like continent names or latitude, longitude lines. A very popular one that teachers love, they asked me to put this on a long time ago, is real-time earthquake data. So let me go ahead and bring that up. And we'll go ahead and, now those are the latest real-time earthquake locations. We can go ahead and put the continents on there, and then we can put on plate boundaries. So there's a bunch of overlays that you can actually layer on top of your data to look for patterns. Let's get some feedback. So I'm going to just adjust one. We have 2 devices in Zoom right now. I'm going to adjust one of them. So we don't get a bunch of feedback. So as I go through this, by the way, there are, if you do a Twitter search, hashtag HoloGlobe, we're still getting the feedback. Let me try lower my volume here, maybe. I can't hear what I'm saying, but at least you will be getting feedback. Okay, so I'm assuming that everyone can hear me. Hopefully everybody is. Anyway, so as I talk about this, we do a Google, we do Google search as well, but if you do a Twitter search, hashtag HoloGlobe, you'll find it's a growing community, and there are people coming up with lessons. There's actually someone who came out with an actual page, kind of like a template, a cheat sheet, you could say, of all the HoloGlobe functions, which is really nifty. And then one of our own people, Tracy, on the Globe site, she also put together a lesson plan that focuses on the Globe Earth System poster using HoloGlobe. So there is things out there, lesson plans, activities that you can use with this. Anyway, okay, so as I mentioned, this is, works in mobile mode. There's different modules. You can learn about satellites, things like that. But the really cool component of this is the augmented reality version. So I'm going to bring back the real-time global cloud coverage.
Hey, Peter.
And I'm going to place the merged cube, the cube I talked about, place the merged cube in front of the device's camera. And now.
Hey, Peter.
Yep.
You're getting an echo. It's just a simple echo right after each word. So it's okay if you talk a little slower, faster. The echo kind of jumbles together.
Okay. I'm going to decrease my volume some. Maybe it's just not. Is that any better? Can't seem to mute it.
Yeah, that's a little better.
Okay. Huh. All right. Well, I'll just talk. Yeah, that's unmuted. Wait, this is muted here. Well, now okay. No, I want it. So it's muted right now. That's what we want. We want it muted. Okay. Yeah, that was okay. But okay. So anyway, so all right, let's put the cube back in there. I just took the cube away. All right, put it on there. Here we go. Get that guy back on here. Ah, look, we're getting double vision. Oh, look at that. Oh my God, look at that. We're getting, wow, recursive reflectance. Awesome. Anyway, okay. That's probably Kevin's process right now. Who knows? All right. So anyway, you got the cube in your hand, and of course we can go ahead and either touch the buttons or gaze at the buttons, one or the other. And we can access all the modules once again. So this is something that, again, this is free. It's online. It's both available on the Google Play Store as well as the Apple Store for iPhone. One more thing I'm going to show you is our large cubes. I'm going to put this one away. And by the way, when you move the cube away, it recenters and goes back into non-AR mode. So if you're a teacher who don't have merge cubes, you just want to start working with the app and have the kids work with the apps, or you want to project the app onto the screen, you can do that just using this mode. So what I'm going to do is I'm going to be a little bold here, and I'm going to actually flip the camera. This camera, I'm going to turn around to our large 2-foot cube. So the idea is that you're going to see the 2-foot cube, the physical cube, and I will walk around it while working AR mode. So you're going to see the two things at the same time, the physical cube and the AR mode working simultaneously. So we'll flip this around. There we go. Okay, so that's our 2-foot huge cube. And I'm going to walk around to the other side, and you should be able to see me. Hello, hello. Okay, and I'm going to go ahead and render. There we go. And we can kind of walk around this. So this is kind of like a magic planet or science on the sphere, but at a fraction of the cost. Now, one of the things that Brian was mentioning to you was the seasons. So there's a seasons activity on this globe, which I think would work very well for big cubes. So let's bring that up. Call it Satellites 101. And there's there's a ton of activities on this. I mean, as I was developing, I was just pouring more and more stuff. I was getting a lot of requests from people. And I was like just adding, kept adding to it. But let's go to the reasons for the seasons, the sun and the earth. So we can go ahead and minimize that. But what we have here is, what happens with the seasons. So the blue circle around the globe is ecliptic. Of course, that's the sun's path. And I can walk around, or kids can walk around with their iPads or iPhones or Android phones and walk around the globe. So maybe you can have kids in different positions around the globe, have them describe. So this is in real time. So notice that we're approaching the winter solstice. So obviously in December, our little sun there will be in winter. Now that little sun is actually what I'm kind of pointing to is a little flare, obviously. And I had someone say to me one time that they think that might confuse kids. They might think that the sun actually goes around the earth, and that, of course, is incorrect. So I'm looking at changing this rendering on the next HoloGlobe iteration, replacing the flare with maybe a pointer, a glowing arrow pointing to the earth. So it represents more of the sunlight direction where it's coming from, not so much a flare. I just like the flare initially because a flare looked really, really cool in your hand.
Okay.
I loved having the flare, but anyway. That may not be the best thing for the kids. So I'm going to probably change that. Because again, I don't want to give kids the impression that the sun goes around the earth, because that's obviously incorrect. But this is simply showing the position of the sun on the ecliptic as we observe it moving across the sky during the course of the year. Anyway, so that's where we are. And so if you ever see augmented reality YouTube videos or people like reaching out, trying to touch stuff, they're doing this, kind of looks kind of funny. What are they waving at, But we can, this exhibits, it's really kind of an augmented reality playground. We could render anything we want here. I mean, the next thing we could do is put, build a augmented reality volcano, or maybe a tornado or something, which would be really cool to have. So anyway, all kinds of things can be done with this. So I'm going to come back over here and flip the camera around. There we go. Okay, and I'm going to go ahead and get out of the share screen mode here. Yep, so I do that. Stop share, there we go. Yeah, that'll be mine.
Let me turn this up.
Everybody hear us now? Are we good? I think we're back. Yep.
Okay.
Ryan's been thumbs up.
Yeah, good. So we'll just wrap things up and leave some time for some questions if you have that. So the idea here, that last piece that Pete showed you, that's our latest piece of research, and we learned from teachers that talked about the small cube and the larger cube is more admirable for classroom experiences or group experiences. And we're just working on our research, or the engineering challenge is to how to build those things. It was a little bit of a challenge for Pete and I to design that one and put it together. So we're looking at a way to do that. So let's just wrap it up by saying, how's all this tie into the GLOBE program and the TREES? So the TREES project campaign. So the idea here is one of the things on HoloGlobe is the ISAT-2. There's no data yet, as it's not coming in on the public availability. Scientists are working on that. And the idea is that we could take that augmented reality HoloGlobe type of deal, and then when people are collecting information, tree information, that data could be put onto the HoloGlobe, so it can be almost a clickable map. So HoloGlobe started out, the reason that it's HoloGlobe, like the GLOBE program, was that we were looking at that to be a way to interact with students from around the world. We started with satellites because that's what we do here mostly. Our research has been involved with that. So the idea that I want to leave you with, and the TREES campaign is a perfect example, is to be outside. Chief concern of all environmentalists is to get outside and to do those trees measurements, and they adopt the pixel measurements, experiment around with AeroCAX and getting your own imagery, learning things like ImageJ or multi-spec, how to manipulate that data, and then to apply that data. And you can do that in your school for a class project, certainly the GLOBE International Science Fair, or in the United States, the GLOBE Student Research Symposiums that are now occurring every year, so you can gear up to use the things. And so we want you to do that. And I'll just say, Brian and I had a conversation way back when he was announcing the campaign, because it's kind of ironic. I started off when I got out of college. My first job was with a shade tree commission in the county where I live in New Jersey. So the values of trees cannot be underestimated. There's so much that it can do. The list is too long to talk about now. Whether you talk about urban heat islands, wildlife, open space, groundwater, the list goes on and on. It's long, for decades been said, if you want to do something for the environment, you only can do one thing, then plant a tree. So you should be all looking at that wherever you live. It doesn't matter whether you're out in the rural areas or you're downtown in an urban area. There's urban forestry programs. And so this is a way to really get involved. GLOBE is there to support you. There are plenty of scientists to help you students in answering questions. And so I'll end here. Thanks for spending an hour with us in New Jersey. And all this stuff, look towards the GLOBE Mission Earth campaign to see the results of our work. And teachers, will throw this out to you also. If we can try to work virtually, that you want to work on some of these projects. We've worked right here locally in New Jersey, and also with Kevin out in Toledo. but we can maybe experiment in ways that we can start introducing this stuff. We would love to see this go all around through the GLOBE program. So thank you, and I'll hand it back to you, Brian. Thanks for having us.
Yeah, thank you, John. Thank you, Pete. So yeah, you learned some really cool stuff, you know, and as you might have seen in the chat, you know, the reason why, you know, we're having this presentation today as part of the webinar is that, as you know, also on our GLOBE website, we are trying to provide you with lots of complementary tools that help you in analyzing the data that you collect through GLOBE, how you can look at data in other ways. You know, on GLOBE, of course, you can look at the data on a map. You know, on the Viz map, you can look at it in the Advanced Data Access tool. But how do you look at data that's similar to what you're taking, but taken by different satellites or instrumentation or aircraft? You know, how do you look at this data in different ways? And HoloGlobe is just one of those ways that you can do that through the ACubed program. So yeah, it's a really cool program, and there's lots of cool stuff that you can do with it. You know, when the ICESat-2 data, you know, once ICESat-2 data is up there, you know, of course, we'll have the tree height data that you can access and take a look at. So yeah, so there's going to be really cool stuff coming, you know, down the line on HoloGlobe, and that's just one of the great tools that we have as part of the campaign to take the data that you're looking at to the next level. I know that was some verbiage from the ENSO campaign, but that's so important. When you're taking the data, to make sense of the data, you really want to look at the data, you know, different ways, whether it be through looking at the comparative satellite data or instrumentation data or other data. So yeah, thanks again, John and Pete, for the great presentation. And a couple things, if you guys, if John, you and Pete would stay on for a second, a couple questions. The one question Peter Nelson answered was from Veronica, but I want to make sure I repeat this so everybody hears in case they didn't see it in the chat. You know, one was, can one merge cube be followed by 10 students using the app on their iPads? And the answer is yes, it can be. Another one is a merge cube made with a 3D printer? I'm assuming it can be, but the actual merge cube is a foam cube. It's a black foam, and it's usually, I think it's like silver paint on it, where the symbols are, the markers for the app. But then also you can actually print it out. And Pete and John, is there a website that you can go, that you know that you can go on and grab a paper copy of the merge cube so that can be printed out and then taped together that you could share with?
Yeah, I can send a link. If you just do a Google search on a merge cube paper template, you'll find it. It's out there.
Okay.
But I can also, Brian, send you a link that you can then blast to everybody.
I found one on a site called ARVRIN EDU. Looks like a college site, but I'm not sure. ARVR.
Yeah, and you know, back with the ICESat-2 launch, you know, I know Valerie had folks make a bunch of those, like 1,000 of those paper cubes.
Yeah.
They're pretty easy to put together. But yeah, I can send a link out.
Okay. Yeah, there were a lot of people who were pasting those cubes together for many hours before the launch.
The one thing I will say, I would definitely recommend buying a cube and supporting the company.
Yeah.
I know that they are concerned about the paper templates becoming. They don't want them to be replacements, and they shouldn't be replacements. In fact, they work okay, but they really don't. I mean, you really do need a merge cube to get the full effect. But it is good just to test out to see if that is something that you would like. Just
yeah. Yeah, it might be good, you know, in a classroom setting, have a couple for the classroom, but of course, some classrooms can't afford, you know, to buy, you know, 30 or 40 or 50 cubes. So yeah, maybe have a couple in the classroom and then have some paper ones as well, you know, that students can, you know, not worry about.
We're doing the research, Pete and I, you know, that's with permission of Merge Technologies to take their template and build it in. You know, basically we're building an educational application and market. So this would be something for all the GLOBE people around the world to get on board with and help this AR type thing come into GLOBE and and help the company, because they just started like a year ago, August, so it's a startup. And how we got into it was Pete also has programmed virtual reality experiences. And I was probably the first one because I'm a hands-on guy, so I want to touch something. And so there's something about, you know, that hands-on learning. And so Pete did a little research online, came up with Merge Cubes. It was just putting the company together. And so we worked directly with them to get this out for their opening. So yeah, so the paper versions are there, but we don't want to put them out of business.
Yeah,
either, so.
yeah, for sure.
If not, go to Walmart, Best Buys, they're on Amazon. Sometimes there's sales, we hear, but go check that out.
I actually found four at a flea market in Laurel, Delaware, and the lady was selling them for $1 a piece. So I thought, wow. And she has no idea where she got them or what they were. So I had to demo it for her at the flea market. Yeah,
Well,
it was very
we'll sell them at the Institute here, and Pete will autograph them for you for $25.
Yeah, yeah.
I'll go to
All
our
right.
nonprofit.
All right, and Peter said something that's really cool about Hollow Globe. Peter Nelson, he said, if everybody can see this, there is a drought layer on Hollow Globe that will help you see where trees could be stressed by temperature or water. So yeah, great application of using Hollow Globe, you know, when you're talking trees. So yeah, that's just one way that we can look at, one way we can look at trees. Does anybody have any questions for?
I have one more comment talking about looking for applications. Pete mentioned it quickly, but any teachers out there or students that can come up with a lesson/application for Hollow Globe, please forward it to us, because that's the next thing we're working on, is trying to assemble kind of a workbook or activity book that will go along with Hollow Globe. That's the next biggest request that we have out there.
Great.
So we'll be glad to include you, have a Globe group book published.
And we'll send you a cube about that.
That's cool.
You can get your name in the book.
All right, does anybody have any other questions for Pete or John? And you can unmute yourself if you need to. Just click the little microphone on the bottom left. All right. So yeah, thanks again, Pete and John, for the presentation. And as I want to stress again, A3 and the Hollow Globe is another tool that we can use to help you complement the data that you're collecting in the field using the Globe protocols as part of the campaign. So very cool stuff. We'll be featuring some more tools in the near future. And remember, our next webinar is less than a week away. It's December 3rd at 8 p.m. Eastern Time, which is 1 a.m. UTC the following day. So once again, I apologize for those of you who have been on ENSO campaign and also the current Mission Mosquito. A lot of those take place at 8 p.m. Eastern Time. So a lot of you I know on here are part of those as well. We're part of ENSO and are part of Mission Mosquito. So it shouldn't be anything different from you. Yeah, well, thank you, everybody. And I'm going to stop recording right now.